Welcome to Unit 8, Lesson 1. We're going to start off with number 1 on the ready. So, points A and B are graphed in the coordinate plane. Graph and label the new points on the same grid. So, our new points. Part A says rotate A, meaning point A, 90 degrees counterclockwise about the origin and label the new coordinates. The new point is A prime. Okay, so we first have to take our point A, which is here in the first quadrant, and its coordinates are 1, comma 2, and we need to rotate it counterclockwise. Now, counterclockwise is going to be this way, right? That's counterclockwise. So if we need to go counterclockwise around the origin, let's make sure that we have, let's put the origin right now just highlighted in black. So we all remember we're rotating around this point here. And once we have that down, right, so we're going to put our new point A prime rotated about that origin 90 degrees counterclockwise. So we're going to go this way. So instead of being 1 to the right and 2 up, we should be 1 up and 2 to the left, right? Because this point will end up being right about here, it looks like. Right? And we don't want a new note, right? So this is our first rotation right there. This is now becoming A prime, right? And we're gonna say that we're gonna label that we've done this in green, right? So A prime is now there, and label the new coordinates. These are now -2, right? And it's only 1 up, -2, comma 1. Oop, I don't love how that last parentheses drew, so there we go. -2, comma 1. You know what? I'll do it one more time. Do it one more time. Let's really make sure. There we go. That'll work. All right. For part B, let's switch to purple. Compare the new coordinates of A prime with the coordinates of A. Oh, we're actually going to do this in green because we're still dealing with the comparison. So let's see. The x value, right? The x value became the y value, right? The x coordinate from A became the y value, right? So x from the normal one became y prime, right? Or the y value for the A prime point. And then the y value, right? The y value became the negative, right? The opposite of the x value, right? The y value, we took it, we moved it to the x, right, value, right, the x value part of the coordinate, right, and we made it negative. So that's what we did to the coordinates there. Let's move a little bit down and see what we can do with part C. Rotate the point A. Okay, we're rotating A again. 90 degrees clockwise about the origin. Okay, 90 degrees clockwise. We're going to do this in purple. And label the new coordinates, and the new point is A double prime. All right, so if it was here, right, we have to rotate it clockwise, means this way. So we have to bring it down, and we know that it was, right, it's sort of like this L shape, right? So this L shape here, if we rotate down, has to become an L shape like this, right? So our new point is going to be here, and we don't want that to be a new point. That's fine. So we do know that this is going to be A double prime, right? And A double prime has the coordinates of, well, it looks like we're 2 to the left, and then 1 down. 2, comma, -1. Right? Or sorry, 2 to the right, my mistake. 2 to the right and 1 down. So 2, comma, -1. So our new coordinates are labeled. And now part D, we're going to continue in purple here. Compare the new coordinates of A double prime with the coordinates of A prime. So basically we're just looking at, right, this, like what happened when we moved it here. Well, our A, right, the x value for our point A, right, the x value from our point A became, right, if we make it negative and put it in the y, in the y slot, that's what we did, right? We took our 1 and we made it -1 in the other variable, right? Our other, the other slot. And then for the Second, right, what do we do with the y, right? Our y value, well, we just moved it and put it right to the x, right? Y went directly to x. So there's sort of a pattern here when we rotate things 90 degrees clockwise and 90 degrees counterclockwise, right? Going clockwise we'll do one thing and doing counterclockwise we'll do the other, but it's always, right, one coordinate stays the same. Oh, sorry, we have to put y becomes x prime, there we go, and negative y prime, there we go. But it's always, right, one becomes negative of the other, or one just becomes the other, right? So one sign switches when we do a 90 degree rotation like this. All right, let's move down a little bit. Rotate point B 90 degrees counterclockwise. All right, we'll do this in a new color. Maybe we'll do orange here. All right, so point B 90 degrees counterclockwise. So counterclockwise is like this, about the origin and label the new coordinate. So, right, and we're already in the bottom left, so counterclockwise from the bottom left is actually going to look more like that. So counterclockwise from there, if we were, right, we're looking at an L like this, so the L has to come 1, 2, 3 and move over to here, right? So that's going to be our new point, and right there is the rotation. So this is going to become B prime. That's B prime with the coordinates. It looks like we are 1 to the right because our x value comes first, right? So we are 1 to the right. Don't love that. Let's go back one. We are 1 to the right. There we go. 1 comma, and it looks like we're down 3, so minus 3. Oh, there we go. 1 comma negative 3. All right, so we've done F. Oops, sorry, that was not F, that was E, wasn't it? We've done E in orange. Compare the new coordinates of B prime with the coordinates of B. Oh, and I realize on this previous one, sorry, I gotta go back in purple, these were double primes that we were doing, not single prime. Right, we were going from the original point to the double prime. So we gotta make sure we have that written correctly. Compare the new coordinates of B prime with the coordinates of B. All right, so our x coordinate, right? Our x coordinate from B was negative 3. That stayed, right, as negative 3, but just switched to the y. So the x became the y for our prime, right, for B prime. And then our y, what happened with our y? Well, our y was negative 1, and we can take that negative 1 and switch it to positive 1 and put it in for our x. So the y value became negative x prime, right? The y value is the same as, right, or it corresponds to the opposite of our new x value. So that's marked in orange. And then finally, we need one more color. I think we'll do this light blue. We'll do that. Rotate point B 90 degrees clockwise about the origin and label the new coordinates. So let's do that. 90 degrees counterclockwise about the origin. So we're going from the origin, 90 degrees counterclockwise. So if our first one I'll write over again was this orange. We need to do, or actually let's do it this way so that it's, I'm gonna rewrite this a little bit because we're rotating the other way, so I wanna show it differently. So rotating counterclockwise, here we go. So it is currently here, but now we can go left 1 and up 3, right? 1, and we'll do this as a slash because I don't want to write over the good work we've already done. So there we go. We have a point up there. We just have to move a little bit. And this is going to be our point B double prime. And what are the coordinates of B double prime? Well, we are 1 to the left, so it's negative 1 to start. And then we're 3 high, so 3 up, so negative 1 comma 3. All right. And we'll rewrite that down here so we can see it. Right? Counterclockwise was, or sorry, normal clockwise was going that way. And our points were -1, 3, right? We went from point B, which is -3, -1, right, to there, and compare the new coordinates. That's our last step. So comparing the new coordinates, right, if we went from -3, right, so our x value to start was -3, and that became the opposite, right, we switched the sign, so negative y double prime. And finally, our y value, our -1, we kept the sign and just became negative, oh, not -1, gotta write -x, but it's not -x, right? Because y is -1 and x is also -1, so y corresponds directly to x. So there we go. All right, let's move on from h. Well, actually, before we do that quite yet, like, do we see the pattern here, right? When we said clockwise, right? I'll switch this to yellow. We haven't used yellow yet, right? But when we did clockwise, both here and here, right? These were both clockwise in parts C and parts G, right? We rotated clockwise. And then comparing the new coordinates, right? X went to -y, right? X went to -y. And then y went straight to x, y went straight to x. So if we did clockwise 90 degrees, this is the pattern. And if we do counterclockwise, right, I'll switch it up again. Maybe we'll do this light green. If we do counterclockwise, right, counterclockwise here, and it's going to be a little bit too high, I think. And counterclockwise up here. Oh, didn't get it. There we go. Counterclockwise up here. Now there's just a little bit different. There's a different pattern. So, and this pattern is, right, x goes to y, right? X goes straight to y. Here we go. X goes straight to y there, right? And then y goes to -x. Y goes to -x, right? So there's a different pattern on each one, and we'll explore that more when we do more with transformations later on. All right, for the set, find the exact perimeter of triangle ABC. On which segment did you need to use the distance formula? So, using distance formula, let's get right into it. ABC. All right, so first off, we know that this is the point, right? That's 1 and that's 5. So we already know that this is from 1 to 5, so that's a distance of 4, right? From, like, this looks like a height of 1, and this is a height of 4. So this is a height of 3, so we got a distance of 3. So we have a 3 and a 4, and now we have to figure out how far is it from A to B. Well, this is the one we need to use the distance formula on, and remember that B is point B, right? Point B is 5, 1, and point A is 1, 4. So we'd have to figure out what is the distance between these two, right? We'd set up our distance formula, the square root of, we'll do the x's first, that's fine. 5 minus 1 squared plus, then we do the y's, 5 minus 1 squared, and then 1 minus 4 squared. If we do this out, we end up with the square root of 5 minus 1 is 4, so 4 squared plus, and then this is -3 squared. This is the square root of 16 plus 9, the square root of 25, which equals 5. All right, so our last distance here, right, is 5. So then we have 3 plus 4 plus 5 are our sides, right? And that's 7 plus another 5 is 12. All right. So total perimeter is 12, right? And we needed AB for the distance formula. All right, let's look down at number 3. Find the exact perimeter of DEF. All right, so D to F right? Our segment DF is from 0 to 4, so that's just 4. And now it looks like we need to use distance formula twice. I'm going to switch colors. We're going to go to purple. So from DF is fine. Let's do DE, right? We actually need to do distance formula twice, so we need it to do for DE and for FE. All right, so DE, right, this is the point 0, 1. E is the point 5, 3, and then F is the point 4, 1. 4, 1. All right, so to find the distance of D to E, we have to set up our distance formula, right? The square root of, we'll do the x's first. Let's do E minus D. So this is going to be 5 minus 0 squared plus 3 minus 1 squared minus 1 squared. Oh, sorry, not that line. There we go. Then we're going to do the the square root again. 5 minus 0 is just 5, so it's going to be 5 squared. Plus 3 minus 1 is 2, so 2 squared. Now we solve each of those squares, right? 25 plus 4, so this is the square root of 29, and we're going to leave it like that. And then for FE, right, let's do from F to E, so we'll do E minus F. Right, so this is going to be the square root of 5 minus 4 squared plus 3 minus 1 squared. We rewrite it. 5 minus 4 is just 1, so 1 squared plus 3 minus 1 is 2 squared. Then we do our squares out, and we get 1 squared is 1 plus 2 squared is 4. So this is the square root of 5. Now finally our perimeter, right, is going to be add them all together. So our perimeter equals 4, right? That was DF was 4 plus our square root of 29 plus our square root of 5. Now, this is actually a perfectly fine answer, right? We can leave it just like this because the square root of 29, we can't make it nicer, so we can leave it as a radical. We could also do decimal, but it said find the exact perimeter, and the only way to write the square root of 29 or the square root of 5 exactly is going to be right as a square root. So we're going to leave it as a square root, right? That's our perimeter. And it's going to be measured in units, I guess, because it's not labeled, right? It doesn't say that these are inches or centimeters or miles or anything like that. So units, we'll just add units here because perimeter is a distance, so we'll label it as such, right? And a distance needs units. So, all right, let's move over to the next one. Oh, we're finding another perimeter. That's totally fine. Let's do that. This is for number 5. All right. It seems like these are all going to be a little bit difficult, but that's okay. Let's call this, right, A, B, C, and D, just to keep things a little bit, just a little bit more organized. So first we're going to do from A to B, right? We're going to figure out from A to B first. All right, from A to B is from 1, 2 to 3, 5, so we'll use 3, 5 as our big point, right? So let's do 3 minus 1 squared plus 5 minus 2 squared. 5 minus 2 squared. All right, we're going to evaluate each of these. 3 minus 1 is 2, which is squared. And then 5 minus 2 is 3 squared. And then 2 squared is 4, plus 3 squared is 9. So this is the square root of 13. All right, so this part here is the square root of 13. All right, from B to C. B to C. All right, we have 6, 6, which will be pretty easy. So we're going to have 6 minus 3 squared plus 6 minus 5 squared. 6, oop, I didn't get the minus. 6 minus 5 squared. All right, so we have 6 minus 3 is 3 squared, plus 6 minus 5 is 1 squared. So this is the square root of 9 plus 1. So the square root of 10. All right, this part here is the square root of 10. Now we're like, oh, I think the lights are about to turn off. So here we go. Come back. Just had to move so that they stayed on, but that's okay. All right, now we're looking at C to D. Let's do that. All right. C to D is gonna be, let's see, 6, 6 to 5, 1. All right, so let's use 6, 6 as the big number again because it's just, right, it's just gonna be easier because all our numbers are gonna be positive. So 6, 6, so 6 minus 5 squared minus, or sorry, nope, that's a plus sign there, plus 6 minus 1 squared. 6 minus 1 squared. All right. So we're going to rewrite again. 6 minus 5 squared. So 6 minus 5 is 1. So this is 1 squared because we do the parentheses first. 6 minus 1 is 5. So we just write 5 squared. Then we can actually do out 1 squared is 1 plus, oh, that's a terrible plus. There we go. Let's try that again. Plus 5 squared is 25. So we have 1 plus 25 is 26. There we go, 26. So the square root of 26 goes down here. And finally, we have to do A to D. Let's scroll down just a little bit. All right, A to D. Right, so our last is the segment connecting A and D. So we start with the square root of, let's use D minus A. So let's do 5 minus 1 squared to start, plus, and then we're going to do 1 minus 2. 1 minus 2 squared as the second part, right? So that's our x's and then our y's. All right, let's simplify this a little bit. Just do what's in the parentheses. 5 minus 1 is, oh, we don't need a parenthesis here. That's fine. Right, 5 minus 1 is 4, so we have 4 squared, plus 1 minus 2 is negative 1. We're going to keep that in parentheses, squared. All right, 4 squared is 16, plus negative 1 squared. If we do negative 1 times itself one more time, right, so 2 of them multiplied together should just be positive 1. So the square root of 16 plus 1 is the square root of 17. So we add that. Square root of 17. All right. And the exact perimeter of the quadrilateral, we're just going to add these together, right? So we're just going to say that the square root of this quadrilateral, or sorry, not the square root, the perimeter, I'm sorry. The perimeter is equal to all of the parts added together. So let's do the square root of, we'll go from smallest to largest. So the square root of 10 plus the square root of 13 plus the square root of 17 plus the square root of 26. That is the perimeter. All right. And finally, we are on the go. We're just doing one of these. So use the given information to fill in the missing coordinates, then find the length of the indicated line segment. All right, so first we're filling in coordinates. We're going to do all the coordinate stuff in green, and then we'll switch. All right, so missing coordinates. All right, first off, stuff that's missing too. All right, I love, right, this whole line is going to be x equals 0 or y equals 0. Right, this whole line, if it's on this line, if it's on the y-axis, we know that that is x equals 0. So I can fill in my x here. My k has an x of 0, and point E has an x of 0. Right, and we know that A, the origin, is already 0, 0. All right, if we have the y-axis, right, on this, or sorry, on the x-axis, oh, that's not what I meant to do. Let's try that again. On the x-axis, right, we know that y equals 0. So we're going to put 0 for all of our y values. 0 there, 0 there, and point A already has 0 and 0, so that'll work. All right, if we go up here, if point B, right, is on this horizontal line, right, if we have this horizontal line and we see that y equals 6 here, right, because for point B it's 6, so we can fill in a 6 there and a 6 there. If we look, right, at this bottom horizontal line, right, we see here there's a -4, so y on this horizontal line must be equal to -4. So we can fill in -4 here and -4 here. And you know what? I'm going to make this negative a little bit bigger. There we go. -4, -4. All right. And what's still missing? Oh, we need our vertical, right? We've got to look at this vertical and at this vertical. All right, so the first vertical, right, we said, let's go on the right one. We know that from D down here, x must be 10 over on this like vertical line. So we can fill in 10s here and here, right, for points B and C. We know that the x values are 10. And then finally, we go over to the left. F is at -10, right? So we know that this line is x equals -10, so we can fill in -10 for H and -10 for G. All right, so those are all of the values, right? We have coordinates now for everything. All right, now let's figure out, we need to find the length of HD. All right, so we're gonna do this in purple. All right, so the line connecting H to D, right, is gonna be like this. So we have to figure out what is the length of the line connecting H to D. All right, so this looks like a distance formula, right? We're looking for H to D. So let's write out, remember our distance formula is the square root of, let's go with, it's going to be a y. Well, we can do x's or y's. It doesn't really matter which one comes first. So let's go, right, x1 minus x2 squared plus this, or sorry, plus y1 minus y2 squared, right? Where the 1 and the 2 are our 2 points. So we're going to say like h is 1 and d is 2. So let's do that. We're just going to read everywhere we see like x1, that's actually the x value for h, which is -10, right? So -10 minus x2, which is +10, squared plus y1 and y2, so we have to use the h values, y, which is 6, minus -4. Oh, I didn't like that. Minus -4. All right, let's just evaluate what's in the parentheses. -10 minus -10 is going to be -20. And we'll keep the squared up there. And then 6 minus -4 is the same as 6 plus 4. So that's just going to be 10. And we'll keep the squared up there. And now we're going to evaluate from some squares. So -20 squared is just -20 times -20. Positive 400. And then 10 squared is 100, so plus 100. So the length of this segment is the square root of 500. All right, so HD equals the square root of 500, which if you wanted to simplify all the way down, we could say is 10 root 5. You could also do that. 10 root 5, right? And that's seeing that there's a perfect square inside the 500, right? We can take out 100, which becomes 10, and then just having a 5 inside. So that is the length of HD, right? Either one of these will be fine. And I believe that concludes the homework help for Unit 8, Lesson 1.